Alright, let's go ahead and talk about dividing fractions too. Okay, so the bar model can be used to divide fractions by other fractions, okay? Like, yeah. So that one's pretty self-explanatory, but let's go ahead and get into it. So, Mr. Felix modeled the problem 7/8 divided by 2/8 in the bar model below. Complete the bar model to show how many groups Mr. Felix will make. Okay. Well, all right. First things first is we're going to look at this, right? And we're going to utilize, again, our technique carried over from the last time, KCF, keep, change, flip. I'm going to start this way over here, and I'm going to write it just a little bit bigger. I have 7/8 divided by 2/8. Okay, well, I'm going to keep my first. I'm going to change my division to multiplication. I'm going to flip my 2/8 to 8/2. Now, before I multiply straight across and simplify, I'm going to look for or try to identify common factors. And I do that diagonally. There's nothing common between 2 and 7, but 8 and 8 obviously go into themselves one time. So that's 1, that's 1. Then when you multiply straight across, you get 7/2. We can't leave it like that, so don't. 7/2. Alright, well, okay, fine. Whatever. 7/2. 2 can fit inside of 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. Put a decimal, 0, bring it down, 10, 5. So, we know that we're using fractions here, so I'll just write the answer as a fraction. Doesn't really matter. But this is going to end up being 3 1/2. Okay? So, there should be, amongst all of these eighths, 3 groups and 1/2 group. So I have 1, 2, 3, 4, 5, 6, 7, because it matches here. My original fraction, which is 7/8. And I need to make 3 groups out of that. So this is one group. This is my other group. And this is my third group. And this is my half group. So that should give me my 3.5 groups. Which makes sense based on how we solved for it, right? We kept our first fraction, we changed our operation sign from division to multiplication, and then we flipped the reciprocal, aka the second fraction. And what they have shaded up here, our original 7/8, is equal to our 3.5 groups, which is shaded down here. Alright, let's keep on keeping on. Here it says use the model below to show how many times 1/2 will fit into 5/6 or 5/6 divided by 1/2. For me, I like this a lot because that's how it's going to actually look, right? Because that's what we have down here as well. So let's go ahead and set that up. We're going to have our 5/6 divided by our 1/2. Again, KCF, this is going to be 5/6 times 2/1. Now, again, you're going to want to look for those common factors. There are no common factors between our 1 and 5, but there is a common factor between 2 and 6, and that common factor is 2. It goes into itself once. It goes into 6 3 times. Multiply straight across, and you should end up with 5/3. Obviously, we cannot leave it like that. So, let's go ahead and divide real quick. It goes into 1, 2, decimal, 0, bam, 0, 8. So, basically we have 1.8. I don't really like that though. Okay, so let's change this. 5, 3. Let's decompose this. 5 over 3. I know I need 3 over 3 to make one whole. What am I left with? 2 over 3. Therefore, I have 1 and 2/3. This is 1 and 2/3. So, let's see how we can group this. Okay. If 1 is 3 over 3, then I should have 1, 2, 3 that fits in this half. So this should be my one group. And then 2/3 should be about here. And this would give me my 2/3 of a group. Cool. Yeah, that works. And then we'll just shade all of this in. Remember, it's 6 out of 6, but we only have 5 of those 6 in our first original fraction, so we only have 5/6 here. But when we divided that by the 1/2, we realized that we actually have one full group, which is going to be the 3 out of the 3, 1, 2, 3, and the 2/3, which is only 2 of the 3, 1, 2. So 1, 2, 3, one group, 1, 2, 2/3 of a group, 1 and 2/3. The next part is actually pretty simple. So when we talk about our flip part, we're talking about the reciprocal, and all they want us here to do is to write our reciprocal, and that's actually probably the easiest thing we can do. All we're doing is flipping our fraction. So 16 over 21, its reciprocal is 21 over 16. 8 over 11, the reciprocal, and I'm going to underline the reciprocal because you're going to see that word probably a lot. The reciprocal of 8/11 is 11/8. The reciprocal of 3 is 1/3. And the reciprocal of 1/5 is 5 over 1. So that part's actually pretty simple. When you see the reciprocal, that's often going to be the second fraction that we end up flipping. Okay? Okay, here we go. Let's do some practice now. There we go. All right. I'm just going to write KCF up here, and hopefully we can utilize that accordingly. All right. So we're going to keep our first fraction, which is 1/4. We're going to change our division sign to multiplication. We're going to flip our 3/5 to 5 over 3. Then we're going to multiply straight across. There's nothing we can do in terms of finding common factors. There are no common factors between 1 and 3, and there are no common factors between 4 and 5. And that's why we're multiplying straight across. This is going to give us 5 over 12, which can't be simplified any further. We go to 6, we're going to still use our KCF. We're going to keep this. We're going to change our division sign to multiplication. We're going to flip this 1/4 to 4 over 1. Well, it turns out here that there are some common factors between 4 and 8. Okay, 4 goes into itself once. 4 goes into 8 twice. You multiply straight across. You should get 7 over 2. Please don't leave it like this. This is not finished. This has to be simplified. So, like in our classroom, we do the cowboy hat and the horse. Which one's going inside the house realistically? The cowboy hat. So hat, horse. Goes into 7 3 times. That's 6. That's 1. Decimal, 0. Drop it. 0, 5. So our answer here is you can write 3.5 or you can write 3 1/2. I think either way is perfectly fine, honestly. Because we're talking about fractions specifically, I guess it'd probably be more appropriate to write it as a half, but we know that these are equivalent. When we get to a mixed number, okay? Similar to the multiplying fractions aspect, we need to do something here, and obviously that something is to walk around Texas. We have to convert this improper fraction into or this mixed number into an improper fraction, sorry. So what we're going to do here is walk around Texas, right? 6 times 2 is 12. 12 plus 5 is 17. So now we have 17 over the 6. Remember, the denominator stays the same. We're going to change our division sign to multiplication, and we're going to flip the reciprocal. So instead of 2 over 3, we now have 3 over 2. But again, we are always looking for common factors. I see a common factor not between our 2 and our 17, but between our 3 and our 6. Okay, 3 can go into itself once. 3 can go into 6 twice. We multiply straight across. We end up with 17 over 4. Obviously, we're not done here. 4 can go into 17 4 times. That's going to give us 16 with the remainder of 1. Decimal 0, put it down. 10, it goes into 10 twice. That'll give you 8. 2, another 0, bring it down. It goes into 5, or 25 times. So we end up with 4.25. 0.25 is 1/4. So really what this is 4 1/4, because 1/4 is 1/4. All right. Let's work on 8. We have 3/10. We're going to change our division symbol to multiplication. We're going to flip our 3/5 to 5 over 3. By now you should be seeing those common factors, because they're pretty obvious in this one. 3 goes into 3 once. 3 goes into itself once. 5 goes into itself once. 5 goes into 10 twice. Multiply straight across, and you literally end up with just 1/2. All right, let's talk about the last few things that we have going on right here. Rewriting the problem. Really not hard. Remember, K, C, F, keep, change, flip. We're going to keep our 5 over 12. We're going to change our division sign to multiplication. We're going to flip our 5 and our 2 to look like that. For the second one, okay, we have 2 mixed numbers, so we're gonna have to walk around Texas here. 4 times 2 is 8. 8 plus 3 is 11. We're gonna have 11 over 4. We're gonna change the division symbol to multiplication, and we're gonna have to convert this mixed number to an improper fraction as well. 7 times 1 is 7, plus 11, or plus 4 is 11, so it should be 11 over 7, but remember, we're flipping it. So it's not 11 over 7, now it's 7 over 11. So you gotta be careful with those, okay? Here, we have to convert. So let's do that. 3 times 5 is 15. 15 plus 1 is 16. Our denominator stays the same. Change our division sign to a multiplication sign, and we flip our 2/5 to 5 over 2. Then we do the work. Fine, let's do it. We have 5 over 12 times 5 over 2. That's going to give me 25 over 24. If I need 24 and I have 25, I have enough for 1 whole. My denominator stays the same. And if I pull 24 from that 25, I'm left with 1 left over. My solution is 1 and 1/24. Here for 11 over 4 times 7 over 11, I'm going to immediately identify my common factor of 11. 11 goes into itself once. 11 goes into itself once. We multiply straight across. We end up with 7/4. 7 over 4. We can't leave it like that. It's an improper fraction. So we're going to say that we can, if we need 4, but we have 7, we can pull that 4 from that 7. That's going to give us our 1 whole. Our denominator stays the same. 7 minus 4 is 3. Our solution is 1 3/4. For our third option, we have 16 over 3 times 5 over 2 here. Again, common factors. There are none between 3 and 5, but there is one rather between 2 and 16. 2 goes into itself once. 2 goes into 16 8 times. When you multiply straight across, you should end up with 40 over 3. Again, you can't leave it like that. So we'll just kind of pull it down here. 40 divided by 3. 3 can go into 40, or 4 once. That's 3. That's 1. Bring down your 0. That's 10. That's 3. That's 9. We're going to keep on keeping on. Decimal, 0. Bring it down. I think it's going to be repeating over and over and over and over again. So it's going to end up being 13 and 1/3. Remember that 0.33 continuous is equal to 1/3. Okay, they are the same, and that's what you would have gotten if I kept going and kept going and kept going. It's just a 3 repeated forever. All right, let's go ahead and solve these real quick. It says circle the name of any student who wrote the division problem with a quotient between 1 and 3. So these are all solvable. It's just that their answers, their quotients have to be between 1 and 3. If not, then we can't circle their names. So let's go ahead and do that. Okay. So we have 2 and 1/2 divided by 2 and 1/3. Okay. Walk around Texas here. 2 times 2 is 4 plus 1 is 5. So now we have 5 over 2. And I'm going to change my division sign to a multiplication sign already, just to be ready. Then here I have 3 times 2 plus 1 is 7 over 3, but I'm going to flip it. So now it's 3 over 7. Okay? Multiply straight across, and I should get 15 over 14, which is the same as 1 and 1/14. 1 and 1/14 is between 1 and 3. So I can circle Keena's name. Not a problem. Here I have 3 and 1/5 divided by 2/7. Okay. Let's do that walk around Texas real quick. 3 times 5, or 5 times 3 rather, is 15 plus 1 is 16. 16 over 5. Let's change that and let's flip it to 7 over 2. Alright, no common factors here, but a common factor of 2 here. 2 can go into itself once, and 2 can go into 16 8 times. When you multiply straight across, you should get 56 over 5. Alright, well, let's go ahead and do that real quick. 1, 5, nothing, 6, 1, 5, 1, decimal, 0, 2. So 11 and 2/5 basically is what you would get here. 11 and 2/5 is not between 1 and 3. Therefore, we cannot circle Milton's name. 1 and 3/4 divided by 2/3. Okay. Let's walk around our Texas real quick. 4 times 1 is 4 plus 3 is 7. 7 over 4. We're going to change our division sign to multiplication, and we're going to flip our 2/3 to 3/2. Cannot simplify with any common factors, so we'll just multiply straight across. We get 21/8. Okay. Well, okay, fine. 8 can go into 21 twice. 21 times 2 gives us 16. 21 minus 16 is 5. Our denominator stays the same. 2 and 5/8 is between 1 and 3. Therefore, we can circle Lily. And that's dividing fractions too.